Hello everybody. Today we'll see about implementation of arrays and some programs related to arrays using Java. So array is a data structure that can hold or store values of similar types. So here you can see, and its index is from 0 to some value n. So there would be n plus 1 elements. We can create a single dimension as well as a multi-dimension array. Here this is an example for a 2D two-dimension array, and this is for three-dimensional array. So we are using array to store values, and here are some questions. uh, there are 5 questions. The first one is to uh, print some values in ascending and descending order. So for that we need to store those values. For that we use an array. So we'll see the program. Here we have a scanner class to take the inputs, and we ask from the user what is the size of the array or how much numbers are we going to store, and here the user gives it and we take it to a variable called as size of integer type. So since we are dealing with numbers, we ask them to enter the elements and we create an array. Here you can see an array is created using the statement, using the keyword new, which is of an integer type, and we are allocating a size in the square braces. So now with the new statement we have that much spaced array or integers spaces that can store some size values. So, and it is referenced by ARR. It's a name, any variable name you can suggest for it. And then we are taking values from the user using a for loop. So a for loop should run from 0 to size. If it exceeds the size, it is actually an error called as array out of bound error. So that would occur, and since here we don't have that problem, we'll proceed and we'll use some sorting algorithm to see whether it's properly sorted in ascending order. So here we are using insertion sort, and the logic of insertion sort is we are copying a particular element. We start from 1 and we traverse to the end, and we take a copy of it, and then we check with the preceding elements whether anything is greater than the particular copy. If so, we are pushing it to the next spot, and then we further continue checking backward. So that is why we have a j minus minus. If either we encounter a smaller number or we encounter uh, the initial point, that is j equals or less than 0, then we come out of the for loop, and then we place our copied variable to that position, the position just after it. So we can attain insertion sort and ascending order through it. Now we don't want a special algorithm for descending order, because well, if we try to traverse what is in ascending, we could get the descending order, and that is what is happened over here. Okay, and then the next program is to find the maximum and minimum element in an array in a two-dimensional matrix. Sorry. So here we ask the user to input the size, that is the row size and the column size. So for that we create, for the given particular sizes, we create a matrix of say R size cross C size, and we ask them to input values. Since this is two-dimensional, we require two for loops, one for rows and another for columns, and we take value using the scanner class object. and uh, we have two other variable s and l, that is to check the minimum and maximum. Just the naming differs. So we assign it to the very first element, and now we are traversing through the two-dimensional matrix, and we are seeing if any value is greater than L. If something is greater than L, from that time on, L is updated to that particular greater value. And after complete traversal, we have L will have the maximum most element in the matrix. And similarly, S will have the lowermost element in the matrix. And then we print the largest element is L and the smallest element is S. Now let's run this program and see. Size I give 3, 3. Now elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll have the largest value as 9 and the smallest element as 1. The previous output was not shown, sorry. So we would display that also. Size less, say it's 6. Now enter the elements, say random numbers 4, 5, 9, 2, 3. Okay, and yeah, sorry, one more number is required. So 1. So we have the ascending order of it 1, 2, 3, 4, 5, 7, 9, and the descending order of it 7, 9, 7, 4, 3, 2, 1. So that also compiled successfully, and now here this is a third program, and this is to check the number of repetitive elements and or to check the number of unique elements, and display what is non-unique and what is unique in a given set of numbers. So here we take the size of the array and we create an array, and we input the array into the matrix. Here what logic we have used is I used a hash table to check the occurrence of it and count the occurrence of it, or basically I would get the frequency of the numbers in the array. So this is only possible if the numbers are all positive, and that's a drawback. So but this is an efficient way of doing. Instead of n square, we would get in a complexity of n. So we find the maximum most element in the array, and we create another array of m plus 1 size, and then if we assign it to 0, and then we traverse through our first array and we assign uh, the AR of j, that is if this main array contains element say 2, here we are incrementing the value of second position by 1. Alright, so if there are all ones, say an element as 4, 3, 3, so in the fourth position you would get 1, and in third position you would get 2. And with that idea we can proceed and check which all are unique and which all are not. If the frequency of the number is 1, that means only one such number is there in that set, so it is unique, else it is not. So here if it is unique, we are counting how many number of such unique elements are there. Okay, and we are saying that the number of unique element is as we have counted, say L here, and the non-unique elements are, we traverse through the second array and we check if the frequency or the count is greater than 1 or not. It cannot be equal to 1 nor 0, because 0 means no such elements exist in our main array. 1 means its frequency is 1 or its count is 1. So the other case is it is more than 1. So all those elements we are trying to print. And when we print, we just try to print the position, because the position refers to the value in our main array. And that's it. And let's run this program and check. Say 5. Our numbers are 1, 2, 3, 2, 3. So unique element is only 1, and that's 1 itself. And number of unique element is 1, and non-unique elements are 2 and 3. Alright, so this is that particular program. And now we'll see the occurrence of the next program is to find the occurrence of a particular number in an array. So just a particular number. So this is basically more easier than the previous question, and the same, not the same, but a linear fashion approach is being used here. Here we traverse through the array named ARR, and we check whether our search element, the element to be searched that we have received from the user, is present. If it is present, we increment the count by 1. Initially count was 0. And finally we print that the number of the times the words, the number we have searched for has occurred C times, because each time we find the searching element, we increment C. And now let's see how it works. So I give 5 and my number is 1.147, and to be searched is 1. So number of time 1 occur is 3. Here it is, we have the answer. And the last one is transpose. Transpose of a matrix is we have to display a matrix of n cross m into m cross n. So its row would be converted to column and column would convert to row. So we have the sizes and we create an array as we have seen earlier in the second problem. And then to take a transpose, we have to read, we are not trying to store it, rather we are trying to display it. So we interchange the row with the column and column with the row. So the iteration would go vertically, and we could get each element and we could display that horizontally. Okay, so let's see how it goes. Enter the size, I give 2 cross 3 and elements 1, 2, 3, 4, 5, 6, and then yes, we got 1, 4, 2, 5, 3, 6. This is it. All the 5 programs regarding array is completed, and thank you.